Good morning, students. So, last day we have solved some problem, some numericals on the basis of basic Rankine cycle, and we have seen the mathematical expressions of mm, basic Rankine cycle, simple Rankine cycle. Then we have derived your work ratio, efficiency, heat rate, steam rate. Now, today we will analyze the cycle and we will modify the cycle and we will see what is happening. So first modification is your reheat cycle. Reheat cycle. So I can say reheat. Reheat cycle. Rankine cycle. Reheat. Rankine cycle. Okay. So here what happens, let me draw the flow diagram. So here happens is that already I have told that there is a boiler. So let me draw the flow diagram. What happens? There is a boiler. This is termed as boiler. Okay. So from the boiler, the steam enters into the turbine, which is known as HP turbine. Which is known as HP turbine. This HP turbine is connected to another turbine, which is known as LP turbine, and this shaft is connected to the electrical network. So from the output of the HP turbine, and this is LP turbine, low pressure turbine, and high pressure turbine. So from the output of the high pressure turbine enters into the boiler again for heating, and this heating is known as reheating. Then after leaving the boiler being reheated, it goes to the low pressure turbine. Then again it expands and it produces some mechanical work. Then after leaving the low pressure turbine, it goes to the condenser where the condensing takes place. So already last day I have told what is the function of condenser. The function of condenser is to change the phase from the mixture of water vapor to only water. Then it goes to the pump. That pump fed to the boiler again. Okay. So this is the total cycle. This is the total cycle. Okay. This is total cycle. So let me tell you one more. This is condenser and this is pump. Okay. So let us give the name. This point, let us take 1. This point is 2. This point is 3. This point is 4. This is 5 and this is 6. Okay, so let me tell you once more that from the flow diagram we are able to see that after leaving the boiler, the steam enters into the HP turbine. Then from the HP turbine it goes to the boiler again for reheating. Then it goes to the low pressure turbine, and after leaving the low pressure turbine it comes to the condenser. In condenser it condenses, that means the mixture of water and water vapor fully converted into water, just like the previous cases, and then it goes to the pump, and in the pump its pressure increases and the pump fed the water to the boiler. So what will be its PV, not PV diagram, I will draw the TS diagram because I have already told that if you will choose the diagram, that will be your convenient. Now your homework is to draw the PV diagram for this case. Okay. Okay, so to draw this kind of diagram, you always have to follow the pressure lines. So how many pressure line is there? So you have to consider one is boiler pressure. Then look at over there, after leaving the HP turbine, again it comes to the boiler, but the pressure has been reduced. So this pressure is known as IP, intermediate pressure. Then it goes to the low pressure turbine, again pressure falls, and in the condenser, it again condenses but at constant pressure. That is known as condenser pressure, CP. So we have to draw the 3 pressure lines. So basically we draw the first 2 pressure line, fast, then it is your intermediate, and this is your condenser vessel line. Okay, so this is your whole diagram. Okay, so this is your turbine output 1, this is your 2, this is your 3, this is your 4, this is your 5, and this is your 6. One more thing you have to remember, that the reheating is done at low pressure, but the temperature at the boiler will remain fixed. That means the temperature of the steam that is leaving initially from the boiler, that is T1, and the and after reheating, the steam leaving the boiler has the same temperature. That means T1 and T3 are same. Okay, so this is the way to draw the diagram. Okay, so the boiler like this, so you have to give the direction, otherwise we will not be able to understand where. So look at the diagram. So from 6 to 1, 1 to 2, 3, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. Okay, now let us give us the heat input. Here it is input, that is Q1. Here also heat is given, that is Q2. Here heat is rejected, that is Q3. Here the high pressure work done from the turbine W1. Here it is W2. Here it is W3. Okay. Now we have to find out separately what is Q1, what is Q2, what is Q3, what is W2, what is W3, what is W1. So I am writing over here. So you just have to do, you have to subtract the enthalpy. What is Q1? It is H1 minus H6. What is Q2? Q2 is H3 minus H2. What is Q3? Q3 is H4 minus H5. Always will take the higher magnitude. And what is W1? W is nothing but H1 minus H2. H1 minus H2. What is W2? W is nothing but H3 minus H4. H3 minus H4. What is W3? It is H6 minus H5. H6 minus H5. Okay, so these are the total enthalpy balance of this reheat cycle. Now we will see that what will be the efficiency. The efficiency of this cycle will be, like this. Eta is equal to, that is output by input, it is nothing but W2 minus W1 plus W2 minus W3 by Q1 plus Q2. Okay, why Q1? Because heat is added 2 times. So what is W1? W1 is nothing but H1 minus H2. What is W2? H3 minus H4. What is W3? It will be H6 minus H5. Okay, by Q1 plus Q2. Q1 is H1 minus H6. Q2 is H3 minus H2. Okay, so this is the way to remember. How the efficiency equation is happening. Okay, so you don't have to remember, you just do the calculation, just see the changes in the enthalpy and you will able to get it. Okay, now your work done is to find out the equation of steam rate and heat rate. Okay, so this is your homework. So next day we will solve now we will solve one problem on this reheat cycle.